And I'm live. All right. Hi, good evening. My name's Joshua. I'll be doing Advent of Code in Lua tonight. Same thing as the last 13 nights. My performance has been consistent. Not good, but consistent. So, let's see. A text message. A text message. Anyway, the problem drops in 3 minutes, so let's set up my environment. Oh, goodness. Let's start with... Oh, goodness. Yeah, let's start with 13. Save that as 14. AOCD arrow 14.input. Let's see. Let's see how last night's is looking. This is, ooh boy. Memoization's still a problem for folks, and the, I was really excited. I don't know if you watched my video last night, but I was really excited by getting to do like modular arithmetic and have a little modular arithmetic brain teaser, and having to drag in my modular division and modular inverse stuff, and I talked really excitedly about that at the end for a good long while, and and I, because I'm an electrical engineer and not a computer scientist, I didn't know about the Chinese remainder theorem, or the name of it is all I know about it, and how to apply it, not so much. And so that was really a puzzle that has a press X to beat puzzle, kind of just like type in the Chinese remainder theorem. Oh, come on. I am less big of a fan of last night's puzzle as a result of that. But I don't know. You've heard me be negative enough about Advent of Code this year. Let's be positive. You have to be excited in order to go fast. Is that true? Boom, boom. Illegal docking. 5-yard penalty. Bits and don't cares. Current bitmask is applied to values immediately before they're written to memory. Okay. Why? This is bizarre. For while true do local line equals io.read star line. If not line, then break end. If line match here. We get big ints by default in Lua. Well, we get 64 ints for a charger. Whoa. A lot like big ints in Lua. Why'd my charger come unplugged? Don't have time to think about that now. Memory is that. If not line of match. If line of match. Mask equals. How do you do them in Lua 5.3? And complement, yeah. Because I am a Verilog programmer, I know how to do this. For KV pairs. I should idiot check myself briefly. Wow. Okay. Let's write a recursive function to do this that uses mask z. If bit m equals 36, then mem adder equals data, return. Yeah. 26, 27, 58, 59. Oh, 59, 58, 26, 27. So the number is 208. Cool. I hope I don't get big inted. Wow, holy shit. 30, 23. Well, I guess being a electrical engineer pays off sometimes. I do bitwise ops all day, every day. I do set and clears all day, every day. And, boy, yeah, I don't think there was anything really complicated about tonight's. It was just typing bitwise ops real fast. I don't know, man. Let's see. X Nvidians. Wow. M Serrano 632. Boy, what happened to you? Well, I don't know. Let's see. How long's Wow, why is this leaderboard taking so long to fill up? This is not that hard. I guess implementing the recursive step, maybe? M. Serrano says, Bissol bar on second star. Bissol bar is a great code word. We type in rot13 in our IRC channel. Bissol bar, of course, being rot13 for off by 1. And of course, everybody knows that now, so there's no point in rot13ing it anymore. But it's funny, so we say Bissol bar, just like Memoize from day 10's catastrophe. Anyway, let's get rid of some of these prints so that. Hey, well. Hey. Okay. Git add 14.lua, 14b.lua, git commit -m14, git push. Yeah, I don't know what happened? Hey, Dr. Deceptive. Welcome back. Yeah, it seemed like a fairly simple recursive thing, and I guess if people were just encoding bitmasks, I don't know. So this kind of would have been fun to write in Verilog, because so Verilog is a language that you use to describe hardware. Foo.verilog module top. I'll show you. And module. Wire. Right, you describe things in terms of wires, not in terms of ints or whatever. Wire 3 down to 0, so this is a 4-bit wire of my wire is 4 binary 0 and 1. Okay, those are perfectly reasonable binary digits. Here, have some unreasonable binary digits, X and Z. Uh-oh, come back. Uh-oh. And then initial $display, my wire is %X. Here, let's make this a little bit easier to see. Let's make that 15 down to 0 and make that a 16-bit hex constant, 01XZ. My wire. My editor's highlighting there is not so good. iVerilog. Have to get install iVerilog. Anyway, the thing that you will see here momentarily is iVerilog foo.v. What did it produce? A.out. Yeah, 01XZ. And so you can obviously only 0 and 1 actually make sense when you go and make real hardware. But X is a particularly interesting value to tell the synthesis tool. It could be anything. Do whatever you like here. Do whatever is the most optimal thing to do. And Z is what they describe in the problem statement is high impedance. And so, for instance, let's make another initial block here. So case on my wire sub 15 down to 12. I don't know what I'm really going to demo here. Okay, I don't actually have any point here in demoing this further. But I guess the thing to note is that X is not entirely a foreign concept if you are used to building hardware. And Z is similarly not a foreign concept. Verilog for state. Yeah, there you go. So you can go read more about this if you find that to be something that is exciting to you. I will be very interested to see in the comments of the Advent of Code subreddit whether people talk about implementing this in Verilog, and I don't know. We'll see. We'll see how many hardware engineers come out of the woodwork. Is leaderboard capped yet? Yeah. Okay. Thank God. Yeah. Anyway, another sprint length problem tonight. But, you know, it is what it is. So